So let us complete the polynomial regression and just focus on this. So now what is polynomial regression? Polynomial regression is nothing but non-linear regression. Earlier we have completed with linear regression. Now we are going with the non-linear regression. Polynomial means non-linear, which is in the non-linear. So earlier, whatever the things we have considered, linear regression. Okay, linear regression, it is a straight line like this. This straight line, y is equal to ax plus b. You can write ax plus b, you can write mx plus c, you can write with respect to b naught plus beta naught plus beta 1x. Anything is same only. Notations are changing, but concept is a is called as quotient, which is also called as slope, and b is called as intercept value. Concept will not change, right? Now, in this case, it is ax plus b. Now, whereas non-linear, if you go with a non-linear, apart from the straight line, if you go any non-linear, that is with respect to a curve like this or a curve with respect to like this, anything comes under non-linear. This all comes under non-linear. Now, whereas non-linear examples are y is equal to ax square plus bx plus c. This is one of the non-linear line, which is a quadratic line. And we are having with respect to y is equal to ax cube plus bx square plus cx plus d. This is also a non-linear line, which is a cubic line. So here, if you observe this one, this is a linear line. This is a non-linear line. This is also a non-linear line, where here the degree is equal to 1. Here the maximum degree of x is equal to 2. Here the maximum degree of x is equal to 3. So now if you go with this linear and non-linear regression, now here, since you are having one variable, only one variable is there, directly you are writing ax plus b and ax square plus this one bx plus c and ax cube plus bx square plus cx plus d. Now, if you are having the two equations, the same thing was represented as beta naught plus beta 1x, where beta 1 is the equal to a and b is nothing but this one. Now, if you are having, for example, two variables are there, x1 and x2. Now, x1 and x2 you are having, then how you are going to write here in this case? Y is equal to a x1 plus b x2 plus c. Or simply you can write like this, beta naught plus beta 1 x1 plus beta 2 x2. You are writing like this, which is a linear, which we have discussed in the linear regression. Now, whereas coming to the non-linear regression, in the non-linear regression also the same to same, where y, it is a single variable. If you are having two variables, a x1 square plus b x2 plus c plus d x2 square plus e x2 plus f. This is for first variable number 1. This is variable number 2. If you are having third variable, you have to add g x3 square plus f h x3 plus I. Simple, right? Just how many variables are there? Those many times you have to take. For each variable, you have to add that. This is called as degree of 2. This is with respect to degree of 1. This is with respect to degree of 3. As the degree increases, just one more variable also will be added. One more quotient also will be added. So now, let us take a simple example where I am having only some total spend versus sales. This is the data set. Forget about the number of records. How many records are there? Forget about that. How many columns are there? Only 2 columns are there. How many x? One is x and one is y. Now, simple linear regression. What is the equation miss? Beta naught plus beta 1x, which we have completed, right? For the same data, if this is for degree of 1, linear, what is meant by linear regression? Linear regression means nothing but polynomial regression. It is nothing but polynomial regression with degree of 1. Degree is equal to 1 is called as linear regression. Apart from degree is equal to 1, anything is called as non-linear regression. Only degree of 1 is called as linear regression. Now, the same simple non-linear regression. Simple non-linear regression. Linear regression equation is this one. Non-linear is if degree of 2 you want. This is degree of 1. Degree of 2 you want. Degree of 2. Now, what is the equation? Beta naught plus beta 1x plus beta 2 x square. For the single only one input variable is there. Now, how this x square from where you got, sir, is nothing but you create one more column. You have to create one more column called as x is there. You can't create x square. Huh? Total spend square you can't create. Huh? You can create one more column, right? This is the variable is available. Just you have to add the one more. Now, just you are applying this. Now you are having total spend square. That is x square is there. X is there. Y is there. Now, if you apply linear regression, what is the multiple linear regression? What is the equation for this? Assume you are having 3 beta y is equal to beta naught plus beta 1 x square plus beta 2 x. 2 variables. Na? If you are having one more variable x cube, the name is x cube. Now, what is the equation? Beta naught plus beta 1 x cube plus beta 2 x square. The name is x square plus beta 3 x. This is same thing, same to same. Just you are adding one more column and you are applying the linear regression, which is a one more column. Which column you are adding is by creating this column with respect to increasing the degree. Degree is called as polynomial. Nominal means degree. Poly means value. X to the power of n. N values can be anything. If n value is equal to exactly perfectly 1 means it is called as linear. Apart from 1, even it is minus 1 also, it is non-linear. 0.9 also, it is non-linear. 0.9999 also non-linear. 1.001 also non-linear. Exactly equal to 1 only, it is called as linear. The degree is equal to 1 only is called as linear. Remaining everything are non-linear. Right? Now here, whatever the equation is there, this is quadratic equation for a single one. If I want to degree of 3, what is the equation? Simple non-linear. Again, simple non-linear only, but this time degree of 3. Beta naught plus beta 1 x plus beta 2 x2 x square plus beta 3 x cube. Sir, sometimes you are writing x cube in the starting, sometimes you are writing x cube in the end. Whatever the order, there is no problem. For each column, one quotient you have to assign. I told you, right? Which order you have to follow is in the extrain, whatever the order is there, that order you have to select. In the extrain, first x cube is there, miss beta 1 is related to x cube. In the order, in the extrain data, first x is there, followed by x square is there, followed by x cube is there, and y is there. Then automatically this is the order. If you are having a data set like this, that is first one is x cube, and next one is s square, next one is x, and next is y. Then what is the equation? Y is equal to beta naught plus beta 1 x cube. First one is this one, right? So for that, beta 1 will be assigned beta 2 into x square and beta 3 into x. Simple. Is that clear? Clear, guys? So now this is for single x only. Single x you have considered. Now the same thing. If you want, you can write the notes. The same thing you write in the notes. In whatever the way you understand, please write your running notes. Don't write as it is, Xerox copy. Don't write. So I have explained in between something, right? From that, whatever you have understand, write that one. Degree of 1 is called as linear. Degree of 2 is called as non-linear. Whether you are applying regression or that is secondary, but degree of 1 is called as linear. Regression means predicting the output variable which is continuous. Simple means 1 x value. Meaning of linear is x value degree is 1. In the given equation, the maximum x value degree is only 1. Is called as linear. Degree of 2 is called as non-linear. Quadratic equation, cubic equation, all this comes under non-linear. If, for example, degree of 40 is there. Now, what is the equation for degree of 40? For degree of 40, for the same thing, same data set. I'm not changing the data set. Same data set, degree of 40. Now, what is the equation? Beta naught plus beta 1 x plus beta 2 x square plus beta 3 x cube plus data 4 x power 4 plus up to so on up to data 22 x to the power of 20. Right? Degree of 20 means up to 20, 40 means 40, 50 means 50, whatever the number. Right? As the degree increases, number of quotient increases. If 1 degree, 1 quotient only. Beta naught will remain constant. Intercept, because for each of them, if you add means total, the numerical value will be only 1. So, but quotient will increases. As the degree increases, quotient increases. Now, okay, sir, degree is equal to 1 to degree is equal to 20. Out of all of them, which is the best one? You try everything. Sir, try everything. When it will be done, just apply the for loop. For I in range of from 1 to 21. And just convert the data, do the conversion first, do the conversion. And after converting, fit into the linear regression. Whatever the linear regression model is there, import the linear regression and fit the data. That's it. After fitting the data, you know how to calculate the test R square, train R square. And just observe which model is giving best test R square without having any kind of overfitting. Now, after observing, you have observed with degree of 4. So, degree of 4 is having high test accuracy, but it is not having overfitting problem. Test accuracy should be high. At the same time, overfitting problem should not be there. Overfitting or underfitting should not be there. For example, test accuracy, degree of 4, test accuracy is 99% you have got. Test. But train accuracy 70 only is there. Then what is the use of this one? There is no use because it is a overfitted problem. Oh, sorry, underfitted problem. Right, test accuracy is very high and train is very low, means underfitted problem. For example, test accuracy 99% is there. Train accuracy 99 is there. Test you have got only 70. Then also there is no use. So you have to select a right model which gives a maximum test accuracy and without having any kind of overfitting or underfitting. Identifying the degree is called as tuning. Identifying the degree, which degree, I also don't know. For the given data set, you might get with respect degree is equal to 2 it might be best, or degree is equal to 3 will be best, or degree is equal to 40 will be the best. We don't know. So we have to try. Sir, okay, sir, you are saying from 1 to 21. Why 20 only? Why 24 or 25, 30 also might be good. Who knows? So first we'll try with 1 to 20. Not even 20 also we'll try. First we'll try with 1 to 11 only. Means let range of 1 to 11 means we are trying with a 1 to 10. If the 10 is the best answer, means maybe 11 might be good. So we'll check from, we'll increase this one to 20. If the 20 is best, means we'll increase this number to 30. For example, between 1 to 10, 4 already you have got 1 to 10, 4 is the best answer. Then what is the use of 1 to 20? No need to check, right? Remaining 11 to 20 also, you no need to check, right? Already the best answer is 4. You got the clarity of the 4. Then why to increase up to 20 or 30 or 40? If the best answer is 10, means sir, maybe 11 might be best. We have not checked now. So we are going to check for the 11. Okay, if the last answer is the best answer, then we have to improve that one. We have to change the value. If in between only the right answer is there, no need to increase the upper value. Is that clear? Right? For example, I have told you earlier the radio example. Radio means not in the dataset radio, general radio, FM. So if you go with the radio and there is an option called as knob, and you have to rotate that knob in order to get the right frequency. You are rotating. Till when you rotate, you'll get the best answer. Best answer means sound. You'll check the sound. If already the sound quality is good also, still you'll increase. Huh? No, right? You will not increase the frequency. Once the sound is clear, you'll stop there only. If the sound is not clear, you'll try to increase. For example, you have tried, let us take 98.3 is the answer. Actual answer is 98.3. You are in the 97.2 FM as of now. And you have to go up to 98.3. Earlier, we are not having auto FM. Now everyone are having in the mobile phones automated. Automated means automatically it is only going to do the tuning and it is identifying the best one. In the backend, it is doing the hyperparameter tuning only. But nowadays, the mobile phones, whatever we are having is inside the FM, whatever we are having, it is automated. But earlier, we are not having that one. So at that time, we used to have with 97.3, 97.4, 97.5, 97.6. For example, when compared to 97.2, 97.6 will get a better sound. Better sound will be here. When compared to this one, better sound. But still, we'll try with respect to, because this is the last number, we'll not stop here. We'll try to improve. That is 97.7. Again, I will get the better answer. I will stop here. When I'm getting better, no, I will not stop. I will continue. I will get better. I will stop. No. 97.9, 98, 98.1, 98.2. I will get better. I will stop. No. I will try with 98.3. I will get better. I will stop. No. Still, I will not stop. Though it is answer also, I will not stop. I will try with 98.4. Now the quality will drop. Now, when compared to 98.3, 98.4 quality will drop. Now, I will understand. Again, I will come back to this one and I will stop here. When the last value is better one, will not stop. We don't know 98.3 is the exact answer. I'm saying if you don't know 98.3 is the exact answer, what do you have to do? If you know that is 98.3, no need to all this. Directly you can turn that one to 98.3 exactly. Means simply to say, in the TV, we'll change the channels now. If you know the channel number, particular, for example, Star Sports you want. If you know that Star Sports is available in the 99, channel number 99, directly you click on the 99 channel number. If you don't know the channel number, then what you are going to do? You'll change every channel now. In which channel is there, you don't know, means what you'll do? You'll check with all of them. Same thing you have to do here also. For the given data set, by seeing itself, we can't identify which degree is the best one. We have to try always. For this data set, for example, for my given data set, degree of 2 is very good, assume. For other data sets also, degree of 2 will be good, means no. For my degree, for example, in my data set, degree of 20 is best, means for other data sets, degree of 20 will be worst, might be. So we have to try with all the options. Is that clear? Now, this is for single variable. Whatever you have written in your notes is for single variable. Now, assume there is two variables, x1 and x2. Now, the question, don't write simultaneously. Obviously, you'll confuse. If you want, you can try. If you want, you can try. If you try and if you confuse only, you'll understand the impact. If you want, you can try. So, now this is beta naught plus beta 1 x1 plus beta 2 x2. This is of degree of 1. Degree of 1 is called as linear. Now, what we are going to do is degree of 2, that is beta naught plus, first I will complete for beta x1. x1, beta 1 x1 plus beta 2 x1 square, completed. Now, I will go with the second one. Intercept will be 1 only, right? No need to add one more intercept. So, directly I will come to the second variable, that is beta 3 x2 plus beta 4 x2 square. This is with degree of 2, which is non-linear. Now, y is equal to beta naught plus degree of 3. First, I will complete with the x1, that is beta 1 x1, beta 2 x2 square, beta 3, x1 square, x1 cube. First variable completed up to degree of 3. Maximum whatever the degree I want, up to that it is completed. First variable. Now, earlier if you are having only one variable, this here we are going to end. But here I am having two variables now. X2 variable also is there. So, I have to add the x2 variable, that is beta 4 x2, beta 5 x2 square, beta 6 x2 square, x2 cube. You have to take x2 cube. This is with respect to degree 3. Is that clear now? Now the same thing. If it is clear, you can write in the notes. If it is two variables, this is the situation for degree 1, degree 2 and degree 3. Just I am showing an example only. Earlier you have seen for the one input variable, what is the equations? That is for degree 1, degree 2, degree 3. Now for two variables, degree 1, degree 2, degree 3. Similarly, I will show for the three variables. Now, in this particular example, whatever I have explained, in this I have not considered the interactive terms. There is no option of interactive terms. If you add the interactive terms, now what is meant by interactive terms? Interactive terms means for beta after this one, there is an option up to degree of 2 na. So you can add beta 5, x1, x2. Now what is the degree of this one? Total degree is 2, right? This is called as interactive term. Interactive term is creating a new column with combination of 2 columns. Combination of 2 columns, or combination of 3 columns, or combination of 4 columns, which is called as interactive terms. Now, sir, what is the use of these interactive terms? Again, don't write, just focus, right? So now, whatever without interactive terms, here, whatever you are having, this quotient value tells about assume that x1 is TV and this is radio, assume. Now, this gives the TV quotient value. This gives the same TV with radio square. This quotient gives with respect to radio, and this quotient gives with respect to radio square, whatever you are having. Now, the thing is that maybe a combination of TV and radio, the quotient, if it is high, means what is the meaning of TV versus radio? For example, you have given an ad on the TV and you have reminded the same thing on the radio. And it means you have done in the radio also. Now, if the beta 5 of x1 and x2, that is TV into radio, if this beta value is very high, what is the meaning of that? It is going to impact the output variable. Yesterday only I have told you, right? As how much change in the delta x. If the delta x is equal to 1, how much change in the delta y will be given by beta value. So if the beta value is very high, means what is the meaning of that? If the beta value is high, means for the change in x, the change in y will be very high. If the beta value is low, means for change in x, the delta y will be low, right? Now here the beta y is having a good value, very good value, and it is very high value. Then we have to consider that TV into radio. But it is not having that much of impact, means you don't need to do with respect to the TV and radio. Now yesterday, if you remember, I have told you an example called as with Lalital Jewelries. Gundu Boss example, right? Now whatever this Lalital Jewelries advertisement is there, now this Delta Jewelries, generally they will do the advertisement on the TV. They'll give some advertisement, and whenever there is an advertisement, special discounts are going, they'll give the advertisement on TV, and next day in the newspaper, on the front page itself, they'll give a big ad. They'll remind us. So in the TV, we'll see this one in the night hours. Generally TV means everyone will watch in the 6 p.m. to 9 p.m. something like this, where serial time is there, right? More number of serials are there, more number of people. Because this jewelry is for ladies only, right? They have to attract the ladies. Now, ladies, most of the time when they will see the TV means serials time only. So they will understand all these things are comes under analysis. So after analyzing, they'll identify which is the peak hours. Whenever the ladies will generally observe the TV means serial time, and they'll post the advertisement between 6 p.m. to 9 p.m. In between, they'll give the ads. Now assume that they have given an ad on the TV that in the Lalital Jewelry some discount is going on or some offer is going on. Assume. Now this generally whoever the ladies has seen the advertisement, the TV advertisement, now they will fix that they want to buy. They'll see the ad and they'll get attracted for that offer or whatever the things, they'll get attracted and they'll assume that they want to buy. Now the next day they'll forget generally. On that time only, while seeing the ad only, they'll get an interest to buy that one. And few of them will forget that one in the next day. Many of them will forget on the next day. And few of them will fix that one and they'll go to the next day jewelry shop. That is secondary. But many of them will forget that one. But these people next day and again on the newspaper, they'll keep a big advertisement to remind us. Yesterday only I have told you the offer now. Again, I am reminding you. Now please come. Right? This is one of the marketing strategy. So first day they will post the advertisement on the TV. Next day immediately they will remind us on the newspaper. Though we have forgot also, they'll remind us. Okay. So they'll remind that this offer was going on. And now based on this how they understand that first we have to go with the TV followed by on the newspaper. They have observed the interactive term where TV versus newspaper term, the beta value is very high, miss. This is having a good impact. If the TV versus radio is high, miss, they'll give the advertisement on the TV and they'll remind on the radio. On the FM, they will remind. The same thing, they'll remind on that. And if, for example, radio and newspaper is there, miss, they'll post the advertisements according to that. So just by observing the beta naught values, beta values, that is quotient values, they are going to decide on which they have to invest. How much amount they have to invest, according to that, they'll invest. Right? So whether to be invested initially on the TV and followed by newspaper, everything has to be done like that or not. That will be decided based on the beta values. And beta values, you have to get the beta values, means first you have to give that one also. So what here we are going to do is, see here. Now the X1, X2, X3 and Y, output variable Y. This is TV, radio and newspaper, and this is the sales. Now for the degree is equal to 1, beta naught plus beta 1 into TV, that is normal X1, beta 2 X2 and beta 3 X3. That is nothing but beta naught plus beta 1 into TV, beta 2 into radio and beta 3 into newspaper. This is called as linear for degree of 1. Now the same thing degree of 2. If you are going with degree of 2, now what happens? Beta naught will be as is beta 1 X1 plus beta 2 X2 X1 square plus beta 3 X2 plus beta 4 X2 square plus beta 5 X3 beta 6 X3 square. Now in this everything, what you have done, these three already there, X1, X2, X3 are there. You are going to create X1 square a new variable, X2 square new variable and X3 square a new variable. You are going to create. Now you are having total how many input variables are there? 6 input variables. So 6 quotient values you are going to get. That is beta 1, beta 2, beta 3, beta 4, beta 5, beta 6. Output variable is 1 only. 6 input variables are there. Just you are applying the multiple linear regression only. But before applying multiple linear regression, you are converting the data. Conversion you are doing. Now, for this, if you want to add the interactive terms, what are the interactive terms? Means X1, X2. You can create one more variable with X1, X2. You can create. You can create one more variable with X2, X3. And you can create with respect to X3, X1. So like this, it is going to create the multiple variables. Now, how many input variables are there? 9 input variables. So now 9 quotients you are going to get. Beta 7, X1, X2. Beta 8, X2, X3. Beta 9, X3, X1. Forget about the order. I'm saying for example only. Don't fix the order. Order is not important. Concept of 9 variables. Here it is the concept of how many variables it is going to create. That is important. What is the order and what is the numbers? Numbering is not important. First variable will be converted with X1 and X1 square. Second variable will be converted as the plain one along with the square. Third one with the plain one along with the square. Right? So total 9 input variables you are going to get. So 9 input variables versus 1 output variable. Now just you are applying the linear regression only. Once again you are applying the linear regression only. But this linear regression, actually they have given 3 variables. You have created remaining 6 variables. You have created that one. Though they have not given also, you have created that one. This is only for the degree of 2. I am saying about degree of 2. Now it is degree of 3 miss. Now you will get with respect to X1 cube, X2 cube and X3 cube also. And along with that, X1 square X2, X1 X2 into X3 square and X3 square into X1. With a degree of 3, whatever the possibilities are there. Along with that, X1, X2, X3. This is also having degree of 3 only. Na? So it is going to create in this way. Is that clear? So this is polynomial regression. Polynomial regression means now polynomial regression. Just we have completed the linear regression in order to predict. Now we are going to improve the higher order. We are just increasing the order. Now we are having with respect to interactive terms. Interactive terms, if you want miss, you can add. If you don't want interactive terms miss, you don't need to add. That is your choice. There is an option within that. Interactive terms is equal to true miss, it will consider the interactive terms. Interactive terms is equal to false miss, it will not consider the interactive terms. Okay. Now, next, here whatever the things are there, this is with respect to the nonlinear data. First, we have to plot the scatter plot. By observing the scatter plot, whether we have to fit the nonlinear data or linear data. So here we are having with if you go with a linear line like this, you'll get the multiple errors. Instead of that, if you go with a line like this, it will be good model. When compared to this one, this is a good model. At the same time, it should not be overfitted. Right? So just if you keep in this mind and if you observe this one, the simple linear regression, 1 beta naught will be observed that one. Now there is an interaction terms. Now also consider the interactive terms. If futures are not only significant with synchronized with others. So for example, newspaper advertising spent by itself is not effective. Yesterday only we have seen that last class. Yesterday means last class. In the last class, we have seen that newspaper is not having any impact and we have deleted that variable also. But it is having a great increase effectiveness if you add the TV versus newspaper. The interactive term of TV newspaper is very high. Individual newspaper is not good. Now from that, what you will understand, if the beta value, that is beta into newspaper, the beta value, what are the beta values there? That is 0.04 is there, assume. But beta into TV into radio is there, TV into newspaper. This beta value, what are the beta value is there? This is, you are having with 4.5. Now every unit change in the TV into newspaper, you are having with respect to 4.5 times with respect to this one. 4.5 units are getting sold. Whereas this one, for every $1, you are going to get 0.04. Now, in this case, it is not having a good impact, but whereas this is having a good impact. Is that clear? So, for which variable it is having a good impact, which variable is not having a good impact, how we can decide is by observing the beta value. Is that clear? To the multiple linear regression. In the multiple linear regression, yesterday, what we have done here, the same with respect. See here, I'm doing once again. I'm executing the code. So here, if you are considering TV, radio, and newspaper, third one newspaper also we have to add now. So now here, beta naught value, what is the beta naught value? 2708 plus beta 1 into TV. So multiple linear regression equation, that is last class equation I'm writing. Beta 2 into radio, beta 3 into newspaper. Now this is a linear regression, linear. Now within the linear only, beta naught plus, that is y variable, y is equal to, that is nothing but says is equal to beta naught plus beta naught value. What is the beta naught value? 2708 plus 0.044 into TV plus 0.119 into radio, 199 into radio plus 0.66 into newspaper. Now, here, please understand this one very clearly. What is the importance of coefficient? Now, what is the coefficient of TV? Coefficient of TV, only TV. What is the value? 0.044. 044. Now, if the quotient of TV, first TV 10,000 I am writing. Okay, 10,000 I am writing. Now, 0.044 into 10,000. Just you are substituting the 10,000. What is the answer you are going to get? 44. 44 or 440? 440. Okay. Now 440 you are going to get. Now 10,001. $1 only you are increasing. You are investing $1. Now from $1, 0.044 into 10,000. If you multiply, what is the output? 440.044. You are going to get. How much increase in the Y is there? Here the increase in X. How much increase in the X? 1. Then how much increase in the Y is there? The increase in Y is equal to 0.44. 0.044. Sorry. The Y is 0.044. This is the Y, which is nothing but change in Y is equal to the beta value of TV. 1000 into 0.044. 440. 10,001 into 0.044. 440.044. Is that clear? So now if you increase $1 in the X value, the X value you are increasing 1, whether it is a dollar or whatever it is, unit, 1 unit you are increasing in the X. In the X, you are increasing to 1 unit, means the change in the X is equal to 1. When the change in X is equal to 1, change in Y is equal to its beta value. Now the same change, now let us go with the third, whatever you are having. Right? Now the same change I am considering, this is quotient of TV. Now the same thing I am going to consider for the quotient of newspaper, which is nothing but 0.006. 0.006. So now whatever you are having, 0.006. 0.006. Now, same 10,000. You substitute same 10,000. Same 10,001. Whatever you have considered for TV, as it is for newspaper also. Now you can see easily the difference. What is the difference? 0.006 into 10,000. What is the answer? 60. Now, if you go with the 10,001, 0.006 into 10,001. 60.006. You are going to get like this. Now, here, the same 1 unit you have increased in the newspaper. Same 1 unit. What you have done in the TV. Same 1 unit you have increased in the newspaper. But how much change in the delta Y is there? Miss 0.006 only. Whereas the change in this one is 0.04. Whereas this one is 0.006. Investment is same. Return is, when compared to this one, this return is very high. Now, in which one you are going to invest then? Both are having, with investment is same, but your return is very high in the TV, means why you will invest in the radio? I mean newspaper, when compared to TV. If the investment is different, means then okay. Right? Now, whereas here, if you consider that, for example, a similar way, TV is not, this newspaper is not having like this, but whereas coefficient of one more coefficient, the coefficient is TV into newspaper. The coefficient is 0.2. 0.2 or 0.03 something, 0.03, assume. Coefficient of TV into newspaper. One of the column is there, right? TV into newspaper is one of the column. For one column, one coefficient also will be there. Now 10,000, same 10,000 if you take 0.03 into 10,000, if you multiply, it is having the impact is, which is 300. The same 10,000, one if you consider into 0.03 into 10,000, you are going to get 3,300 into 0.03. Now change in the one, here the change in Y is 0.03. When compared to newspaper individually, it is not having any impact. But if you are having the same thing, TV into newspaper, it is having a good impact of 3, which is almost equal to individually applying on the TV. Now the same amount on 10,000 instead of applying on TV, you will apply the 10,000 on the TV and newspaper. Together you will invest the amount of 10,000. Is that clear? Whether you have to invest on this or not, for example, this value is very less like this. Now what you are going to do? You will not invest. You will ignore that particular variable. If the beta value is very good, miss, you will invest according to that. Is that clear? So now here in the polynomial regression, we are going to do the same. So here the interactive terms means nothing but individually newspaper will not be that much of great, but if you add the TV and newspaper together, that might be good, might be. Compulsory, it is not rule. Might be, might not be. Anything can happen. Just you have to observe that one. Right? So consumers watching TV ad will create some sales, but consumers who watch TV and later reminded to a newspaper could contribute even more sales. This conclusion they have got after observing the beta. If the beta value is low, miss, this rule is not applicable. If the beta value is high only, this rule is applicable. Right? So we have to check that one. So we have to create the interactive terms. If you are interested in interactive terms, means create the interactive terms. No, sir, I'm not interested in interactive terms. I'm only interested only to increase the TV square. I want to invest only purely on TV or purely on radio or purely on the newspaper. Tell me which one is the best one. Don't tell me both the combinations, sir. Sir, I will say that first you invest on the TV certain amount and invest some amount on the newspaper. I have told you like this. For example, you are having on 10,000, you are having budget of 10,000 you are having. Now, instead of investing 10,000 on single TV, invest 8,000 rupees on TV, 2,000 rupees on newspaper, something I have told you, something like this. Now, this is having a good impact or not, that we have to check. Right? So, whether to, if you want interested, sir, I want to invest only on TV or only on radio or only on newspaper. Tell me out of these three variables, which is the best one, miss? Which are the beta is having high, that is the best variable. Which are the beta is low, that is least variable. Right? Is that clear? Now it is clear. Now see here. Now the same thing we are going to do in the polynomial regression. See, just observe. Okay, don't write because code is same as it is, nothing difference. So in the multiple linear regression, what I have done in the starting, first I have downloaded import the libraries, same thing I'm doing. After that, what I have done in the multiple linear regression, collected the data and I have seen. Same thing I'm going to do here also. And what I have done here, next after this, I have done the EDA, that is correlation coefficient, and along with the scatter plots, that is pair plot. So I'm going to do the same to same. Describe function, pair plot, and correlation coefficient. Why correlation matrix I'm observing? Because is there any collinearity problem or not? To check the collinearity problem is available in my data set or not. For that reason, we are going to check the correlation matrix. Now, after that, what I have done? Here I have considered in the X all the three variables and Y says. So same to same. All the X variables I'm going to consider in the X, in the output variable Y. Now, what is your X means? Three variables, that is TV, radio, and newspaper. Now, if directly I apply the linear regression, it is degree of 1. Now what I'm going to do is I want to create a new columns. What are the new columns I want to create? Miss TV square, radio square, and newspaper square. If interactive terms I'm not interested, only the squares. If interaction terms means TV into radio, radio into newspaper, newspaper into TV. Like this I have to create. Right? So if I'm not interested with interactive terms means only square, square, square only. So what I'm going to do? From sklearn.preprocessing, import polynomial futures. And where you are going to take the polynomial futures, degree is equal to 2. Means you are trying to improve the degree to 2. And where interactive terms also you are considering. Now, this whatever the conversion, I'm going to use this polynomial futures of degree is equal to 2 with fit and transform. Fit and transform on X. What is X? This is the X. For this X, I'm going to increase up to the degree of 2. So now degree of 2 means it is going to increase up to the degree of 2. And now you are going to get this X. X is 3 variables. Now whereas X poly is you are going to get total 9 variables, out of which this is X1, this is X2, and this is X3. See here, if you want, you can observe. What is your X1 variable? 2,30,100. Same 2,30,100. That is X1. Next one is 37,800. Same 37,800. This is X2. Next one is here newspaper. X3. Same X3. Now this is a combination of X1 square, X2 square, X3 square, X1, X2, X2, X3, X3, X1. You are going to get like this. Total 9 variables it is going to create. Now, just you have written the degree of 2 and fit and transform on the given data. For example, given data is having only one column, that is total spend. I am having only one X variable, and degree of 2 means what it is going to do? TV and TV square. If you are having only one variable means TV and TV square. If you are having two variables means X1 and X2. Two variables, and you want to go with the degree of 2. Now what it is going to do? X1 square, X2 square, interactive terms of X1, X2. If you want, you can check. So what I'm going to do is here in the X, I'm considering the variables like 2 columns. I'm taking the 2 columns. One column is TV and the second column is radio. One more column radio. Now how many input columns are there? Now for these two columns, what I'm going to do is I'm going to apply the, now if you see your X, only two columns are there. Okay, two columns, that is X1, X2. This is your, that is X is nothing but TV and radio. You are having only two. Now if I go with the degree of 2, this is degree of 1. Degree of 2 means TV, radio will be as it is. Along with that, TV square, radio square, TV into radio. I am going to get like this. Let us see. I am going to apply the degree of 2. Degree of 2 means it has to create with a degree of 2 like this. Now, whatever the X poly is there, just let us click on the X poly. Total 5. That is first TV, radio. And TV square, radio square, and TV into radio. Total 5 variables. Is that clear? TV, radio will be common as it is. TV square, radio square, and TV into radio. If you add the interactive terms, if you don't interested in interactive terms means here you have to write, in this case you have to write interactive terms is equal to false. Interactive terms. So interactive terms, interaction only. So interaction is only is equal to false. Now it is going to create. Now if you write with respect to interaction only miss true. So you can create with respect to this one, right? Is that clear? Interaction only miss, you are going to get only interactive term, that is X1, X2 and X1, X2. Only interactive term. Only interactive term you are going to get. Interaction only. Interactive only means interaction term only you are going to create. You are not going to create with X1 square and X2 square. You are creating only with X1 and X2. You are keeping the same thing, but here interaction term only. So generally we'll not consider this interaction only. We'll go with respect to a degree, normal degree. Generally why polynomial regression we are applying is to improve the degree only. Right? Now here, if you are considering the TV, radio, and the third one, newspaper also. Newspaper. Now you are having 3. And now according to that, X1, that is TV, radio, and newspaper. Degree of 2. TV square, radio square, newspaper square, TV into radio, radio into newspaper, newspaper into TV. Total 9 variables it is going to create. Is that clear? Done? So now total 9 variables are there. Now this is your X. Earlier X is 3 variables. Now your X is 9 variables. 9 variables is your X. And you are going to apply the train test split on by considering X poly. In the train test split, you are not going to take as only X poly. This whatever the 9 variables are there, that one you have to consider and you have to divide into X train, Y train. Again, you are going to fit the linear regression. Now automatically it will apply the linear regression only. 9 variables, it is applying the linear regression and you are going to get 1 intercept coefficient and 9 quotient values. So this is the quotient of with respect to the first one. E means 10 to the power of. E means 10 to the power of. So here whatever the value you are seeing 5.478 into 10 to the power of minus 2. That is equal to 0.05478. That is the meaning. Okay. E to the power of minus 0.2 means 10 to the power of minus 2. E to whatever the E is there, that is 10 to the power of meaning. Right. Now if you observe this one, total 9 quotients are there. Now using these 9 quotients, you are going to predict on the X train, you are going to predict on X test, and you are going to calculate the train RMSC, test RMSC, train R square, test R square. In the S test class, did I remove any of the row? Without removing all, if I consider all the rows and all the columns, and I have applied the multiple linear regression, and what is the output I have got? Test R square, train R square, what is the test and R square? This one. One is 90 and one is 86 by considering the 3 columns. The same 3 columns I am considering here also. I have not removed any one of the row also. Same 3 columns, right? TV, radio, newspaper, I have applied with respect to multiple linear regression and I have got 86 and 90 and out of which one of the variable is not significant and I have dropped that one. But whereas in the polynomial regression, the same TV, radio, newspaper, this time I'm going to get with respect 98 and 98. Now for this data set, linear regression is best or polynomial regression is best? That one we are going to select. Now within the polynomial, now I have selected only degree of 2. Now if I want degree of 3, what I have to do? Just you have to change here degree is equal to 3 and execute once again. Now again do the train test split. Again you do this one. Again now you see the quotient values. Again you predict. Again you calculate the train R square, test R square. Sir, every time I have to do shift enter like this. Every time changing the degree is equal to 3, degree is equal to 4, again shift enter, degree is equal to 5, shift enter, degree is equal to 6, shift enter. Every time I have to do like this. Because here in the multiple cells you have written, you are doing the shift enter for different cells. If you have copied everything in one cell, why you have to do that many times? One time shift enter only. Copy entire code into one cell. It is mandated that you have to write in different cells. No, right? There is no rule like that, right? So just what I'm going to do, see here. Okay, I'm converting. Why I have to see the X poly? I know already this how many variables it is going to create. I no need to see. Just I'm copying this code also. Copy and paste here in this only. In the one cell only, I will do this one also. It is mandatory that I have to write in the separate cell. No, right? I'm going to do the same thing in the same cell. I will copy this one also in the same cell. Copy, paste into the same cell. Now, whereas prediction also do in the same cell. Where is prediction? That is this one. These two also you do in the same cell only. Copy, paste. And after that, calculating the train R square, test R square. That is also copy. And this one, that is test R square. This one also I am copying. Copy and I am pasting. Now this is called as test. This both has to be printed now. So I'm going to use the print. Otherwise, by default, only last line will be printed. So for 2 lines to be printed, I have to use separately the print option. Print this one, print this one. This one also I'm writing print. Okay. Now everything was done in the single only. One shift enter only. Now change the degree. Degree is equal to 2, shift enter. Degree is equal to 1, shift enter. Degree is equal to 9, shift enter. For each degree you can see. No need to do that many times shift enter, shift enter, shift enter. I mean, you no need to execute multiple cells. Copy everything in the single cell only. In this single cell only, pre-processing is done. Train test split is done. Modeling is done. Prediction is done. Evaluation is done. It is not mandatory to have in the separate cells now. So then if it is not mandatory in separate cells, then why you are showing in separate cells? Means because I'm explaining for you. I'm not working in the company. I'm explaining. When I'm explaining, I have to make it simplified. When I'm working, I can bring everything. Now I no need to check what is extra and I no need to check how many variables are there, right? In the company, I will check how many variables it is going to create. Because here I am learning, I have to show you how many variables it has been created. That is x1, x2, x3, x4. How many variables it has created, I will show you. Whereas in the company, I will not work like this. And now here, whenever I'm working, automatically it has to change. Means this I am going to keep it as I. Now I am going to write for I in. For I in range of 1 to 21. And everything I am going to move to like this. That's it. Now automatically it will apply the for loop. Just it will apply the for loop for different I values. Okay, whatever the different I values are there, it is going to apply. Now just I have brought everything in the first I is equal to 1. It is going to apply the entire things. I is equal to 2 entire things. I is equal to 3 entire things. I is equal to 4. I is equal to 5. I is equal to 6. For each value it is printing. For each value it is printing the everything. Invalid syntax. Okay. Right? This is for I is equal to 1. These two are for I is equal to 2. These two are for I is equal to 3. These two are I is equal to 4. These two are I is equal to 5. First I is equal to 1. Degree of 1. Degree of 2. Degree of 3. Degree of 4. Degree of 5. Can you observe in the degree of 2 what happened? Train accuracy is 76. Test accuracy was dropped to 62. Overfitting has started from the degree of 4. Now in the degree of 5, 93 R square of train R square, test square is minus 29, 2.29. After that, 17, minus 17 train R square, test R square is still more worst. Now like this, sir, now whatever the values are there, this one also you can append into the empty and take the empty list. Train R square, you create an empty list, test R square, you create an empty list and append that one. Separate the test R squares, train R squares. Append. You are having append, right? Empty list you can create and you can append, right? Right. That's it. Now, how many models you have done? 20 models. 1 to 20 models you have applied. 20 models you have applied. If you write 200 means 200 models. Out of 200 models, which model is best miss? So automatically, whether it is 200, whether it is 2000 also, the best one is with respect to, this is the first one. This is the second one, degree of 2. This is the third one, degree of 3. Now, when degree of 4 is worst, means either 2 or 3 only you have to select. Within the degree of 2 and 3, which is having the highest test accuracy? This is train. First one is train, test. Train, test. Now, out of these two, which is having highest test accuracy? 98.08, 98.93. So, this one I am selecting, degree of 3. Whether it is whether you have selected 200 also, final answer is degree is equal to 3 only, final answer. So your choice is, your priority is test accuracy. This is your top priority. But at the same time, you should not have overfitting problem. Now these two models are not having any kind of overfitting. This is not having, this is not having. This one also not having. These three of them are not having any kind of overfitting. But out of these three, which is having highest test accuracy, means this is having the highest test accuracy. Right? So like this, we are going to do. The same thing I have done. See here. So if you come down, just I have taken the train R square, test R square, and for I in range of from starting from 2. Degree of 1 already we know that it is linear regression only, right? And same thing I have done. Just appended. I copied everything. Copy paste only I have done. Okay, polynomial features, train test split, modeling, prediction, and whatever the score is there. Train scores I have appended in the train R square list. Test R squares I have appended in the test R squares. Now, if I open the train R squares, these are the train R squares, these are the test R square values. Out of which we can clearly identify these are all of them worst. Your answers are from 1 to 4 only. These all of them you can't consider. 20 only is not worst, means we'll try with 21 also. Na? We'll check with 21. Na? 22, 23 we'll check. What is the use? Here 5 only is not applicable. Then what is the use of 25, 26 degrees? 5 only is not applicable. 1 to 4 only answer is there. Now within 1 to 4 only you have to identify which is the best model, which is not having the higher either overfitting or underfitting with a good test accuracy. So just what you are going to do, just I am applying this comparison and whatever the values I have got, just I am making a equation like this. So if you want to calculate based on the R square, means you go with the R square. If you are interested with RMSE, means select the RMSE. Okay, first this is called as conversion, pre-processing. This is called as train test split. This is called as modeling. This is called as prediction. This is called as evaluation. Train RMSE, test RMSE, evaluation. After evaluation, finally identifying is called as model selection. So pre-processing plus after that train test split, after that modeling, after that evaluation. So in between prediction, first you have to predict. After modeling, prediction. After prediction, you have to do the evaluation. After evaluation, you have to identify which is the best one. Model selection. And out of all the models, whichever is the best model is there, that model you have to save and share it to the deployment team. Remaining models, keep it with you only. If you delete also, no problem. The best model only you have to say to the deployment team. Okay. While explaining to the client, for example, client has given to you TV, radio, newspaper. For TV, $1,50,000. For radio, $45,000. For newspaper, $90,000. What is the estimated cost? Miss, just you substitute this one in the First, this one has to be converted to pre-processing. The data has to be converted. Converted means TV square you have to create. If you ask with respect to this one, see, for example, your model is ready. Okay. For example, what is your model is ready? Which model you are selecting, miss? I'm selecting the model. Whichever is the best model, miss. I'm choosing the degree is equal to 3 as my final model. Okay. Which has given this one. This is my final model. Degree of 3 is my final model. Now this model, model.predict on TV, whatever the TV value is, that TV of $1,50,000, comma, radio $45,000, comma, newspaper 90,000. If you give like this, it is going to throw an error. It will throw an error. If you observe this one, it is going to throw an error. Why error? Because whatever the degree of 3 is there here in the xtrain, this is your model. Now for your xtrain, let's observe what is your xtrain dot shape. What is your xtrain? If you observe xtrain, in this, how many values are there? And what is the shape of xtrain? If you ask what is the shape, miss, you are going to get 19 futures are there. Now you have to create 19 futures. How you can give just 3 futures as the input? For example, assume that degree of the 2 is best model. Let me explain in a simple way. X1, X2, X3. Okay, degree of 2 is the best one. For degree of 2, X1 square, X2 square, X3 square, and X1, X2, X2, X3, and X3, X1. This is a degree of 2. Assume that degree of 2 only, yours is best model is degree of 2. Okay, this is your best model. Okay, what is your final model is this final model where it consists of 9 input futures. Now you have created with this model with 9 input futures. Your futures are xtrain is 9 input futures, whereas x1, x2, x3, x1 square, x2 square, x3 square, and this is the total 9 input futures you have given. Now, whenever you are having 9 input futures, this final model, whatever the final model is there, this final model was fitted on the xtrain. Now, from where you got xtrain? Xtrain you have got it from the xpoly. From where you got xpoly? After transforming. This is not the original x, right? After transforming, you got the x. The original x is consisting of 3 variables. After transforming that one, that is poly of x, you have got with 9 variables. These 9 variables you have done the train test bit. Miss, now for model, with how many variables you have created the model? This model was created with how many variables? Final model was created with how many variables? 9 variables or 3 variables? 9 variables. When it is created with 9 variables, how you can give for 3 values only as the input? You have to give 9 values as the input. Now that 9 values, how we have to give the 9 values? Miss, before giving that 9 values, first these 3 values you have to do the transformation. So first whatever you have to do is, you have to convert these 3 values. Whatever the 3 values are there, x1, x2, x3. These 3 values, you have to do the transform. You have to apply the transform. After transforming that, now it is going to convert to 9 values. For example, let us take like this. x1, x2, x3. 3 values are 1, 2, 3 for your simplicity. 1, 2, 3. Just a small numbers I am taking. 1, 2, 3. Now, what is the 4th value? 1. What is the 5th value? x2, x3. Right? Now, the same thing what I'm going to do is here. First, I'm going to create an np.array. np.array. Whatever the np.array of these 3 values. Whatever the 3 values are there. 1, 2, and 3. These are the 3 values. Now, these 3 values, now it is an array. Now, how to convert an array to a data frame? pd.dataframe. You know, right? Or directly you can create the pd.dataframe for whatever you want. pd.dataframe only. Either you can go with the numpy or you can create like this directly. Where I'm going to use the dictionary. Using the dictionary of x and list of 1, 2, 3. Okay. This I'm going to save it as some trial version. So I'm going to make trial. Data frame name called as trial. Now what I'm going to do, if I open this trial, here I'm having with respect to the values of 3 values only. sorry, 3 columns. I want to make 3 columns. This is not the values. I have to create as a columns, 3 columns with respect to 1 row. I should not create like this. I should create with respect to, that is x1 variable, x1 of 1, comma, x2 with respect to using 2, comma, x3 variable. I have to create x3 variable using 3. Right? Now, if I execute this trial, whatever the trial is, the trial. pd.data frame where dictionary x1, x2, x3. Key value, key value, key value. What is the error then? Using all scalar values must pass as an index. Okay, you have got like this. Now x1, x2, x3, 3 columns are there. Now, whenever this data frame is there, that is trial. Now, what you are going to do is poly underscore final underscore poly. See, I'm going to do this one. Final under this, whatever the polynomial converter is there, this converter, whatever the converter is there, converter dot transform. I'm going to do the transform on the which variable? Trial variable. I'm going to apply the trial variable. On the trial variable, I'm transforming that one. So trial. Okay. Now here you are going to get 1, 2, 3, 1, 2, 3, 4, 6, 9. So same with respect to these values. That is 1, 2, 3 is this one. That is first value, second value, third value. Again, this is with respect to first one is x1 square, and this is where is this one? This one is x1, x2, and this one is x1, x3. This is x2 square, and this is x2, x3, and this is x3 square. That is the order they have followed. Okay, so this is x1, x2, x3, x1 square, x1, x2, x1, x3. With x1, everything was completed. Next, x2 square, x2, x3. Next, x3 square. So in my case, x1 is equal to 1, x2 is equal to 2, x3 is equal to 3. So 1, 2, 3, followed by 1, followed by 1 into 2, 2, followed by 1 into 3, 3. Next, 2 square, 4, 2 into 3, 6, and 3 square, 9. Is that clear? So just now, if you ask the question, sir, here you have not applied the fit underscore transform, just you have applied only transform. This is the important question. Okay. So what is the difference between fit and transform and transform? Fit and transform means first it is going to calculate, and after that it will transform. Whereas transform is already whatever you have created, it is going to convert only. It is just converting. In this case, it is going to calculate and convert. When you have to calculate and convert means for train data, you have to do the fit and transform. For the test data, you have to do only transformation. Now, whatever the data you have got, this data, after converting the polynomial regression, this data you have to pass into the information for this one. Now, whenever you are executing the model, for that model, you have to give total 9 values. So the meaning is simply to say, first you are going to take train data. Okay, you are going to take train data. For the train data, what you are going to do is first you are going to convert with respect to this one pre-processing. You are going to do the pre-processing on the train data. You are going to do the train data and test data. That is, if you consider the test data separately, train data, if you do the pre-processing, and after that you are going to do the modeling, and after that you are going to do the prediction and evaluation. Completed. Now test data means new data, completely new data. Test data means new data, whichever you want to predict, new data, unknown data. Now for this unknown data, from where you have to start means first this unknown data has to pass into the pre-processing, and after pre-processing it will pass into the predict directly. It will skip in between the modeling. It will skip the modeling option. It will not do the modeling now freshly. It will directly predict into the model. Unknown data, it will directly predict. Is that clear? So here, if you give 9 values only, it is going to predict. Now you can save that model. Already I have shown you how to save, right? By using the dump. Right? In the last class, I already shown you in the simple linear regression itself, I have shown you. Just you are going to create the dump file and you are going to create this one. And you are going to predict on the new data. Whenever you are predicting on the new data, first you have to transform the data. After transforming, directly you have to apply on the predict. Without transforming, you should not predict that directly. Because the model was designed with 9 input variables, you are going to give only 3 variables. So 3 variables, then it is going to throw an error. So these 3 values has to be converted to 9 values. After converting to 9 values, we have to use the model.predict, because the model, whatever the model is there, the model was designed for 9 input futures. It is not designed for 3 input futures. If the number of input futures are not matching, it is going to throw an error. Is that clear? So now what is meant by polynomial regression? Simply to say polynomial regression is nothing but converting to polynomial futures and applying the linear regression is called as polynomial regression. Converting to polynomial futures and applying the linear regression is called as polynomial regression. Clear? Is that clear? Yes. Done. Converting of polynomial futures plus application of linear regression is called as polynomial regression. That's it. The data has to be converted to polynomial futures as per the degree. And which degree is the best one, that you have to identify. So wherever the value you don't know, for example, in the train test split random state number, we don't know. Select different types of random state and identify which is the best random state number by giving to the model. Apply the for loop. Identify which is the best random state number. In the tomorrow, we are going to learn the new algorithm called as, not tomorrow, in the future. We are going to learn an algorithm called as KNN. KNN means K nearest neighbors. Where K we don't know. We don't know what is the value of K. If the value of K is fixed means, they'll tell that 5NN neighbors model only, right? They'll rename it as 5NN. If the K is fixed of 10 means, they'll tell 10NN model. If the K value is fixed of 8 means 8NN model. But they don't know the K value. That is the reason they have told it is as KNN. Now you have to identify the K value. Now how to identify that K value means by applying the for loop only. By giving the different values of 5 K values and identify which is the giving the best one. Every time. Remember, this is called as tuning. Tuning means just applying the for loop. Apply the for loop for which values you want to check. Apply the for loop. Writing the for loop and identifying which is the best one. Whichever you want to try, all the values you keep here. Sir, for example, I want to try with not in the range of 1 to 20, sir. I want to try with 1, 1.4, 1.9. Like this, I want to try, sir. Then create the list. Whatever you want, create the list. For IN list. For IN list and you apply the logic. Same logic. Whichever the values you want to try, you try. For IN range means numbers, integers. If you want particular these things means, you try with a list. Whichever the numbers you are interested, select that numbers only. For IN list, now automatically I value is equal to 1, I is equal to 1.4, I is equal to 1.9. If it is applicable means, it will calculate. If it is not applicable means, it will throw an error. What is this? You are asking like this. Polynomial regression will not consider with respect to 1.4. Degree should be only integer value. It can't be the float value. It will throw the error. The degree can be only an integer type. It can't be a float type. Right? It will throw an error. If it is able to fit means, it will fit. If it is not able to fit means, it will throw an error. Is that clear? Polynomial regression is clear and how to identify the best accuracy is clear. Now, after doing all these things, now the same data, whatever the data is there, they have given me the data set called as TV, radio, newspaper, and I have gotten one Excel sheet. Now, different things I have applied. I have applied first MLR. I have applied the polynomial regression of degree is equal to 2, degree is equal to 3. I have applied. And finally, after doing all these things, finally I concluded polynomial regression with degree of 3 is giving a better one, and this gives with a test accuracy of 98%. And I'm going to share this one to the client. So for the given data, for your requirements, I have predicted with 98%, and this is the model, and we are going to share the model. Now, whatever the model we have shared, he will apply like this. He will keep the values of 3 values, and he will see this one. Simple. If he knows Python miss, he will write the load, poly, dot, transform, all these things. If we don't know Python miss, we have to create the website for that also. That is called as deployment. I will show you in the next further class. That one also I will show you.